Unit 3, we're going to take a look at systems of equations. So in the first section, we're going to solve a system by graphing. Warm up, can you draw lines with each of the following? So the first is a line with a positive slope. So a line with a positive slope is any line that's increasing from left to right. So it can look something like this. It can be a little bit less steep. It can look like this. Notice it can be in the negative quadrant as long as it's increasing from left to right. We consider that a line with a positive slope. A negative slope would be decreasing or going down from left to right. So anything that looks something like this, again, as we go from left to right, if it's going down, that would be considered a negative slope. It can look something like this as well. Zero slope would be flat. So if you're thinking about like skiing, zero slope, there would be no hill. So here's zero slope, just flat. Any line that looks like that would be considered zero slope. And then undefined slope would be straight up and down. So any line that went straight up and down, it would be considered undefined slope. If you recall the definition of slope, it is rise over run. So let's talk about why this would be zero slope. If we pick any 2 points on a line, we can see we go up 0 here over 1. And if you take 0 divided by 1, you're going to get 0. I could choose like these 2 points. We go up 0 over 1, 2, 3, 4, and again 0 divided by 4 is 0. So again, this is a zero slope if it's flat because you're going up 0, and then you can go over any amount. 0 divided by any amount is still 0. So 0 is flat. It's different than undefined. So if you take a look at undefined, this one, if I choose any 2 points, it goes up 1 over 0. And if you try to divide by 0, you get an error undefined. And the reason is the number is just really big and your calculator can't calculate it. So for example, if we take 1 divided by a number close to 1, so if I type that in, 1 divided by 0.1, let's see what happens. And we'll get 100. So again, 1 divided by 0.01 is 100. What if I take like 1 divided by let's do 3 zeros into 1. So if I take 1 divided by point and 3 zeros into 1, we get 10,000. So as you can see, did I squeeze it in there? As we divide by numbers closer and closer to 0, our answers are getting really big. And if you try to divide a number by 0, the number is just so big we say it's undefined. So what you need to remember is an undefined slope is straight up and down. A zero slope is flat. They are actually two separate things, two different things. So let's take a look at graphing an equation given the slope and the y-intercept. So we have talked before in this course and other courses about slope-intercept form, where you have y on one side, and the slope is the number next to the x. So here it's the m value, which m stands for modulus of slope, and then the b would be the y-intercept, and that's like your starting value, y-intercept. The y-intercept is when the x value is 0, where your graph starts at. So if we take a look at graphing, let's start with the y-intercept. So here's our y-intercept. We're going to start at -1. And our slope is 2, and that's the same as 2 over 1, and it's positive. So we're going to start the y-intercept. I'm going to go up 2 over 1 and make a dot. Up 2 over 1 and make a dot. We are looking at linear equations or linear functions, and so we know it's going to be a straight line. So it will look something like that. All right, so again, start at the y-intercept, graph your slope, connect your dots. Let's try the next one. Here the y-intercept is 5. How do I know that? It's because it's the number by itself. So we're going to start at 5. Our slope is -3/4. And since it's negative, instead of going up and over, we're going to go down and over. So this time we're going to go down 3 over 4 to the right 4. So again, we went down 3 and to the right 4. And when you do that, we'll get a negative slope if we connect our 2 points. We'll try to make it a straight line here. And again, a negative slope goes down from left to right, so we went down, but still to the right. Okay, let's try graphing this one. Here the y-intercept is 2, and the slope is 0. And so we're going to start where the y-intercept is 2, the slope is 0, means it's going to be a horizontal line. So there's the line y equals 2. And let's graph the next one. X equals 4. So where does x equal 4? Well, x equals 4 here. Actually, all along this line, x equals 4. So the line x equals 4 is actually a vertical line. It's easy to get these two confused, a y equals line and an x equals line. Because the x axis is horizontal, we're used to thinking of x lines as horizontal like the x-axis. And because the y-axis is vertical, we're used to thinking of y equations as being vertical. But it's actually the opposite. So here we notice that if it's going to be a y equals equation, it's a zero slope, so it's going to be flat. So you do need to know if it's y equals, it's flat. And then if we have an x equals, it's going to be actually a vertical line. So x equals will be vertical, and y equals will be horizontal. All right, so let's practice going the other way. If I give you an equation, you should be able to graph it, but also if I give you a graph, you should be able to write the equation. So if we take a look at the first one right here, I'm going to start with my y-intercept, or you could start with the slope. This y-intercept is -2, and our slope is positive. We're going up from left to right, so I'm just going to pick any 2 points. This goes up 2 over 2, and if I write that, I can reduce it so it's a 1. So it's going to be positive, and we can write plus 1x, or if the slope is 1, you can just write x, which would imply that the slope is 1. So here's the equation of A. Let's try B. So this one, the y-intercept is 3. Our slope is negative because we're going down. So we're going to go down 2 over 3. So there's one way to write it. Keep in mind you can switch the order. We can write -2/3 x plus 3. They mean the same thing. Notice this y-intercept is positive for both. The slope is negative for both. So you can write this equation a few different ways. All right, let's take a look at this line right here. The y-intercept is 2 and the slope is 0. So it's just y equals -2. And this one is our vertical line, and all along this line the x values are -3. So again, if it's a y line, it's going to be flat or horizontal. If it's an x line, it will be vertical or straight up and down. So your goal today is to write and solve a system of linear equations by graphing. So definition, a system of equations is a collection of 2 or more equations with the same set of unknowns. So a system is 2 or more equations. So let's take a look at the first situation. Danny and Carter both plan to run for a spot on the school board in their city. They must collect a certain number of signatures to get their name on the ballot. So far, Danny has 15 signatures, but Carter just started and he doesn't have any yet. Danny is collecting signatures at an average rate of 5 per hour, while Carter can get 10 signatures an hour. Can you define variables and write a system of equations for Danny and for Carter? All right, so our variables here, we're going to have signatures and time. So I'm going to say x is the number of hours, and we'll say y is our number of signatures. All right, and let's graph the equations. I'm going to write out the equations first. All right, so let's write Danny's equation. He starts with 15 signatures, and he collects 5 every hour. So there's Danny's. And then for Carter's, he doesn't start with any, but he collects 10 every hour. So his y-intercept is 0, doesn't start with any, but he collects 10 every hour. So there are their equations. Let's graph them. So Danny's going to start at 5, and he's going to collect, he's going to start at 15, I'm sorry. And he's going to collect 5 every hour. So here's 1 hour, so go over 1, up 5, over 1, up 5. We'll do that a few times. And there's, whoopsies, there's Danny's line. And then let's graph Carter's. His y-intercept 0, so at time 0 he starts with 0, but he collects 10 every hour. So go over an hour, up 10, over an hour, up 10, over an hour, up 10, and then we're going to connect. I should keep extending. All right, so it says C, assuming that the rate of collection stays the same, eventually the two will have collected the same number of signatures. How many signatures will they both have? So signatures is the y value, so if we go across, that's going to be 30 signatures. How long will that take? So that's time. Time is the independent variable on the x-axis, and we can see that's 3 hours. Another way to write that, since I defined x is hours and y is signatures, I can write it as a coordinate and say 3:30, where x comes first, 3 hours, and 30 signatures comes second. All right, let's try the second one. Khalid, an office manager, needs to find a courier to deliver a package. The first courier he is considering charges a fee of $20 plus $3 per pound for the package. The second company or courier charges $10 plus $4 per pound. Define variables and write a system of equations that represents the situation. All right, so again, let's say X is the number of pounds, which the abbreviation for pounds is LBS or hashtag. So there's pounds, and we'll say again that Y is the total amount or total cost. And if you notice in our graph, notice here's the weight in pounds. That's the independent variable or X, and then the cost is the dependent variable, and that would be Y. All right, let's write our two equations. So the first one I'll do in purple. So the first one is $20 flat fee plus $3 for every pound. And the second company charges $10, but they charge $4 per pound. So depending on how heavy your package is, one of these is going to be cheaper than the other, unless they're tied, of course. All right, so let's graph the first one. So the first one starts at 20. Oopsies, first one I did purple. And it goes up 3 every hour. I'm going to make a table so I can get good numbers here because it goes up by like 10, 20, 30, and 40. All right, so we know at 0, at 20. All right, so at 10, I'm going to plug in a 10 right here and solve. 3 times 10 is 30. 30 plus 20 is 50. Let's do another one. Let's do 20 pounds. So 3 times 20 is 60. 60 plus 20 is 80. All right, so I'm just finding coordinates by plugging in, and I'm going to graph these. So 0, 20, 10 is at 50, and 20 is at 80. Okay, so there's my first line. And I'm going to make another table for my second courier. And again, just plug in. I'll plug in like the same coordinates. All right, so at times 0, it's going to be $10. Let's plug in a 10. So 4 times 10 is what I'm plugging into is 40 plus 10 is 50. And 20, let's plug in 20. 4 times 20 is 80. 80 plus 10 is 90. All right, so let's graph these. At 0, 10, so this one's cheaper at first. But if you notice, at 10 pounds, they both cost $50. And at 20 pounds, this one jumps to 90. So this one's cheaper until you hit, I'm trying to get my straight line tool here. It's not working. There we go. Pretend that connects it. All right, so if you take a look at it, the red line, the second courier, is cheaper until it hits 10 pounds, and then it becomes more expensive. So it says, Khalid determines that given his package's weight, the 2 courier services are equivalent. How much is that, and what do the packages weigh? So we can see that at 10 pounds, they both weighed $50. After that, courier 2 becomes more expensive than courier 1. Okay. We're going to graph one more together, and then your assignment today will be on Delta Math. And on Delta Math, it's called Day 1 Solving Systems by Graphing. And you'll be using the technology there to form your graphs and to find where your systems, like the solution of your systems. The solution of a systems would be where do they cross. All right, so the last one, 2 car rental companies are running specials this month. At Rima's Rentals, customers pay $50 to rent a mid-sized car for the first day and $10 each additional day. At Nadia's Rent-A-Car, the price for a mid-sized car is $30 for the first day and $15 for each additional. All right, let's define our variables. So here, we're going to say X is the number of days because that's the independent variable, and Y will be the cost. The cost depends on how many days you've rented the car. All right, so for Rima's, they'll pay $50 to rent the car plus $10 per day. And at Nadia's, they'll start at $30, but it's going to be $15 per day. So it looks like Nadia's is cheaper at first, but at some point, will Rima's become less expensive? So let's graph. Again, I'm going to make a table. Okay, so I'm going to do Rima's in red. And I'm just going to pick some points. I'll do 0 days, I'll do 4 days, and I'll do 10 days. Okay, so I'm just going to plug in. So at 0 days, it's $50. At 4 days, it's going to be 40 plus 50, which is 90. And at 10 days, oh, it's not going to fit. I'm going to go a little bit lower then. Let's go like 6 days. How about? All right, so 6 days, that's 60 plus 50 is 110, still off the graph, but that's fine. All right, so 0, 50 is right here. 4, 90. I'm going to go up to 4 and then 90. And I'm going to connect those. Ooh, that was a pretty good line. Okay, so for Nadia, I'm going to do the same thing. I'll just use the same points. Okay, so for Nadia, she's $30, and then 0 and 6. Okay, 15 times 4, so is that 66? So this is 90. Oh, okay. So that 90, they're the same. Okay, so let me write this down. Okay, so 0, 30, and then 4, 90. This is when they're the same, and then Nadia's becomes cheaper. Okay, so the solution to the system is where do they cross? So here the solution is where they're tied, and that would be at 4 days. The cost for both of them is $90. So that's the solution to the system. At 4 days, it's $90. And C says which company is cheaper at first, so it's the purple line. We can see that Nadia's company is a little bit cheaper until 4 days, and then it becomes more expensive. All right, so today, again, you're going to log on to deltamath.com. You're going to look for Day 1 Solving Systems, and you're going to try those problems, and we'll go over any questions that you have next time in class.